morning, dear students. Good afternoon, dear students.
Good
Good
afternoon, sir.
afternoon, sir.
Uh, Welcome to the chemistry class. Today we shall study about the addition of ammonia and derivatives and the oxidation of the aldehydes and ketones. Uh, in the last period, my dear students, we have studied about few things that I'm going to revise for you. We have studied about the addition of alcohols and addition of hydrogen cyanide. We have seen that on addition of hydrogen cyanide we get cyanohydrin. At the same time, on addition of alcohol we get this way either the acetal or ketones. So we have seen that the aldehyde give a hemiacetal of aldehyde and acetal of aldehyde. Same way, my dear students, we can see that a ketone will give us the ethylene glycol ketal when it reacts with the uh, ethylene glycol. So here you can see that hexanthreone can give ethylene ketal of hexanthreone when it reacts with the ethylene glycol. So this is how, my dear students, we truly understand about the uh, production of the acetals and ketals. Acetals and ketals are hydrolyzed with the aqueous mineral acids to yield corresponding aldehydes and ketones. Now in today's class, my dear students, we want to study about the addition of ammonia and its derivatives. So let us study about the addition of ammonia and its derivatives. You can see here on your screen that we are going to study about the addition of ammonia and its derivative into the aldehydes and ketones. The nucleophiles such as ammonia and its derivatives. In general, we will write the ammonia and its derivative as a NH2Z. Add to the carbonyl group of aldehydes and ketones. The reaction is reversible and catalyzed by the acids. So the equilibrium favors the product formation due to the rapid dehydration of intermediate to form C double bond and Z. This is the product that we can form. So we have aldehyde or ketone that reacts with the NH2Z to gives us the COH and finally from that we get C double bond and Z, which is the carbonyl derivative. We get it as a product. So we can use the various substances or various groups as a Z. If Z is hydrogen, our reagent is ammonia, and the carbonyl derivative produced is a C double bond NH, which is known as imine. If Z is R, that is any alkyl group, we will have amine. We can have primary, secondary, and tertiary amines this way. So we can have these amines, and this is how you can find the substituted imine, which are also known as the Skips base. We have alcohol, which the reagent is NH2OH, which is hydroxylamine, and this hydroxylamine gives oxime. We have NH2NH2, that is what it is known as the phenyl hydrogen, and phenyl hydrogen gives us the phenyl, sorry, NH2NH2 is hydrogen, and hydrogen gives us the hydrazone. We may have the phenyl hydrogen, NH2NH6H5, that gives the phenyl hydrazone. We may have a 2,4-dinitrophenyl hydrazone, 2,4-dinitrophenyl hydrazine, that gives us the 2,4-dinitrophenyl hydrazone, which is yellow or orange color, yellow, orange, or a red color solid. So this is how, my dear students, we understand. Same way, if we have the semi-carbazide, we may get semi-carbazone. So this is how, my dear students, we understand about the addition of the ammonia and its various derivatives, my dear students. When we understand about the ammonia and its various derivatives, let us understand the ammonia and its various derivatives with their example. If we take acetaldehyde and allow it to react with the ammonia, we get acetaldehyde imine. This O generally is being removed by the reaction, and this C and N, they combine with the double bond here. So you get this product. Same way if you have formaldehyde and if you allow it to react with the ethanamine, sorry, it's not ethanamine, but it's a methanamine. You will get methyl formaldehyde imine. Same way, if you take acetone and allow it to react with the hydroxylamine, you will get acetone oxime. You know, oxime is something that you get common for all when the carbonyl compound reacts with the hydroxylamine, and what compound reacts with the hydroxylamine, that is put before the word oxime. So this is how we can get the various products. If we have acetaldehyde and allow it to react with the hydrazine, we will get acetaldehyde hydrazone. The process is very simple. These two hydrogen removes, this oxygen removes, water molecule is being removed and the double bond is formed. Same way here, even if you look at these two hydrogen removes, this oxygen removes, and then there is a double bond between this carbon and nitrogen. So propanone, when it reacts with phenyl hydrogen, we get propanone phenyl hydrogen. Please remember it, it may be the red, orange, or yellow colored substance. So please remember that it may be the red, orange, or yellow substance that we get as a phenyl hydrazone. Same way, my dear students, if we take benzaldehyde, this benzaldehyde reacts with 2,4-dinitrophenyl hydrogen. Again, the same thing happens. These H2 and this O are being removed, and there will be double bond between this carbon and nitrogen. And this is how you get the benzaldehyde 2,4-dinitrophenyl hydrogen. Suppose you take cyclobutanone. So when you take cyclobutanone, again this oxygen is being removed, this hydrogen is being removed, so water molecule is gone, and you get the double bond between this carbon and this nitrogen. So you can get the semi-carbazide of cyclobutanone. So please understand, my dear students, these are the very simple reactions. I have covered many of the questions from your exercise by putting these examples. So please keep in your mind that we have studied many of the exercise questions while we are studying the various examples. Now, my dear students, we are going to study about the clemenson reduction. Please pay attention. This clemenson and wolfkishner reduction are very similar to each other. So we will study them together. Let us first study about the clemenson reduction. If any carbonyl compound is treated with zinc amalgam, this ZnHg is known as the zinc amalgam, and concentrated hydrochloric acid, definitely HCl. C double bond O group is converted to CH2 group and it gives the appropriate alkane. So this is what, my dear students, we need to understand, that aldehydes and ketones, when they react with the Clemenson reduction reagents, from aldehyde and ketone we get the respective alkane. For example, you can see that this carbonyl group turns into CH2 group. So if you take ethanol, you will get ethane. If you take methanol, you will get methane. If you take propanol, you will get propane. So respective hydrocarbons are produced. Just you need to remember that ZnHg oblique HCl is the basic reagent for the Clemenson reduction. Now, my dear students, we are going to study about the wolfkishner reduction. In the wolfkishner reduction, the reagent is KOH, that is dissolved into the ethylene glycol and then followed by heating. So if any aldehyde or ketone is treated with the hydrazine, that is your NH2NH2, followed by heating with the sodium or potassium hydroxide in a high boiling solvent, ethylene glycol, we get alkane. So first, this carbonyl carbon needs to be treated with the hydrazine. When it is treated with the hydrazine, we generally get hydrazone. That is what we have already studied about, that we get hydrazone. We have just studied it. This hydrazone, when it's treated with the alkali, that is potassium hydroxide or sodium hydroxide, which was dissolved into the ethylene glycol, and if it is heated, we get respective alkane. So you can see that from ethanol, you get ethane, from benzaldehyde, you get toluene, from cyclohexanol, you get cyclohexane. So this oxygen is being reduced and we get the two hydrogen placed for it. So this CH3, CH3, this you will get benzene and CH3, this you will get only CH2. So this oxygen is being removed and two H are being added by the reduction. We have studied two type of reduction. What are those two type of reduction? First we have studied the reduction called clemenson reduction. Dear students, what is the reagent for clemenson reduction? Bachcho, what is the reagent for clemenson reduction?
zinc amalgam.
Please try to speak. You are right.
Zinc amalgam.
See, for clemenson reduction, we use Zn Hg, that is zinc amalgam in the presence of HCl. And for wolfkishner reduction, we use NH2NH2. What is the name of NH2NH2? It is known as the phenyl, it is known
Hydrogen.
as the hydrazine, and then it is allowed to react with KOH in ethylene glycol. And due to this, my dear students, and we need to provide heat. So this is how any carbonyl compound, my dear students, any carbonyl compound can be easily converted to the alkane. So aldehydes and ketones that can be converted to alkane or hydrocarbon by clemenson reduction or wolff-kishner reduction. Now, my dear students, we want to study about the oxidation. Oxidation of any organic compound is done using the two different types of reagent. So we have these reagents which causes oxidation are called oxidizing agents. We have strong oxidizing agents, we have mild oxidizing agents, nitric acid, potassium permanganate, potassium dichromate, they are known as the strong oxidizing agent. For nitric acid, we can write HNO3. For potassium permanganate, we write KMNO4. For potassium dichromate, we write K2Cr2O7. But CrO3, that is chromic oxide, tollens reagent, fehling reagent, they are considered as the mild oxidizing agent. Let us see how the oxidation of aldehydes and ketones takes place. Let us study it in detail. Aldehydes on oxidation with a strong or weak oxidizing agent gives carboxylic acid. Please remember that aldehydes, when they are oxidized, they give the respective carboxylic acids. Ketones are generally ketones are generally oxidized under vigorous conditions only. Vigorous condition means the conditions of higher temperature and pressure, that is strong oxidizing agents and elevated temperatures. So whenever you want to do the oxidation of ketones, you will have to create the vigorous conditions, and these vigorous conditions are the strong oxidizing agents and elevated temperatures. Their oxidation involves carbon carbon bond cleavage. So oxidation of these compounds causes the cleavage of the carbon carbon double to afford a mixture of carboxylic acid having lesser number of carbon atom than the parent ketone. So you will get the product which has the lower number of carbon than the parent ketone. Here you can see I have shown you one ketone. The ketone carbonyl carbon has bonded with one side RCH2 and another side it is bonded with the R-CH2. So on oxidation it gives us the four product. First, by the cleavage of C1 and C2 bond. So my dear students, if this bond is being broken, then what happens? We get RCOOH from this and we get R dash CH2 COOH from this. But if, my dear students, the bond between C2 and C3 is broken, then we will get RCH2, R dash COOH and RCH2 COOH. So this is how, my dear students, we are going to get four products: RCOOH, R dash CH2H, CH2COOH, RCH2COOH and R dash COOH. So this is how the ketones undergoes the oxidation. Now first, let us look at the tollens test. We have seen that tollens reagent is a mild oxidizing agent, and we are going to study about the tollens test for the aldehydes. Let us pay attention. This tollens test on warming an aldehyde is specially used for aldehyde with the freshly prepared ammoniacal silver nitrate. This ammoniacal silver nitrate is prepared by adding, AgNO3, that is silver nitrate, with excess of NH4OH. That is also known as the liquor ammonia or um, ammonium hydroxide. So when freshly prepared ammoniacal silver nitrate solution, which is known as the tollens reagent, a brighter silver mirror is produced at the bottom of the test tube or in the vessel the test has been proceed. So formation of silver metal, because during this reaction between the aldehydes and ketones and ammoniacal silver nitrate, silver metal is produced and this silver metal deposits on the surface of the vessel in which the test has been performed. The aldehydes are oxidized to the corresponding carboxylate anion. Carboxylate anion is your COO minus. So we can say RCHO turns out to be RCOO minus. The reaction occurs in alkaline medium because NH4OH that we have used to make ammoniacal silver nitrate is basic, and that is why the reaction moves into the alkaline medium. You can see now the reaction that I have shown you, that RCHO, this is what it is known as the ammoniacal silver nitrate. So when ammoniacal silver nitrate remains works in the presence of OH minus, we get this carboxylate ion, we get silver. This silver metal which is produced deposit on the wall of the container, and ultimately we get the silver mirror. Same way, my dear students, we have fehling test. So fehling reagent comprises of two solutions. One is known as the fehling A solution, which is an aqueous copper sulfate. Another one is known as fehling solution B, which is alkaline sodium potassium tartrate, which is also known as the Rockel salt. My dear students, you may be asked that what is Rockel salt. So Rockel salt is the alkaline solution of the sodium potassium tartrate, my dear students, and this sodium potassium tartrate is known as the Rockel salts, which is utilized uh, as a failing B solution, my dear students. Now let's move forward. These two solutions are mixed in the equal amount before the test. So before the test, these two solutions are mixed in the equal amount. On heating an aldehyde with failing reagent, a reddish brown precipitate is formed, is obtained, and aldehydes are oxidized to the corresponding carboxylate ion. So these reddish brown precipitates which are obtained, they are obtained due to the Cu2O, or you can say Cu plus 1. Let's study. This is your RCHO. We know that Cu plus 2 comes from the copper sulfate, which was blue in color. So aldehyde, when it reacts with the fehling A and fehling B solution, the carboxylate ion is produced, the reddish brown precipitates are produced. And if the reddish brown precipitates are produced, we can say that the compound gives the fehling test. Now the very important point about this. Aromatic aldehydes do not give fehling taste. Please remember that aromatic aldehydes do not give fehling taste, but aromatic aldehydes give tolerance taste. So if you want to identify whether the given aldehyde is aromatic or aliphatic, if the given aldehyde is aromatic or aliphatic, how will you do it? You will allow the aldehyde to react with the fehling reagent. If it gives the reddish brown precipitates, it is aliphatic. If it does not give reddish brown precipitates, uh, it is aromatic. So this is how, suppose you are asked that distinguish between benzaldehyde and acetaldehyde. See, they may do not directly ask you even ethanol. They tell you acetaldehyde and benzaldehyde. So, my dear students, we can easily understand that benzaldehyde will not give fehling test, but acetaldehyde will give fehling test and will produce reddish brown precipitates. So, if the given compound produce reddish brown precipitates, it is acetaldehyde, and if the reddish brown precipitates are not formed, it is benzaldehyde. This is how, my dear students, we can understand about the tolerance test and failing test. Remember, my dear students, that the tolerance test and failing test are not given by ketone. You can see now on your screen, the new shared screen. The first statement of that screen tells you a very important information, dear students. Can you read that information, bachcho? Can you read that information, what I am highlighting? डियर स्टूडेंट्स आर यू देयर बच्चे क्या आप लोग हैं उधर
Yes, sir.
हाँ
Ketones
तो
do
पढ़ तो
not
लीजिए
give
एटलीस्ट
tolerance
इतनी
test.
इतनी बार तो कर लीजिए
Ketones do not give tolerance and fehling
यस
test.
प्लीज रिमेंबर दैट ketones neither give tolerance test nor give fehling test. Ketones don't give tolerance or fehling test. And remember that only aliphatic only aliphatic aldehyde give fehling test. Aromatic aldehyde give both tolerance as well. Aromatic aldehyde give or both aromatic and aliphatic aldehyde give tolerance test. So even if you have two compound, one is benzaldehyde and another is acetaldehyde, you allow them to react with, allow them to undergo the tolerance and failing test. The benzaldehyde will undergo tolerance test, and the acetaldehyde will undergo both failing as well as tolerance test. So this is how you can distinguish between the two aldehyde if they are aliphatic aldehyde or aromatic aldehyde. Now, my dear students, we need to study about the oxidation of methyl ketone, which is known as the haloform reaction. So, this is the haloform reaction, which also help us to distinguish between aldehyde and ketone. Distinguish between aldehyde and ketone. Because there is only one aldehyde that gives haloform test. All the other aldehyde do not give haloform test, and that is why this can help us. Let us study the haloform test. This haloform test can also be called iodoform, or sometimes it is known as a chloroform or bromoform, but it is mostly we consider it as a iodoform because iodoform CHI3 is yellow in color. So we get a proper taste because of the iodoform. So this haloform is sometimes referred as a iodoform test even. Aldehydes and ketones having at least one CH3CO group. They should have at least one CH3CO group, or or alcohols with at least one CH3CHOH group. They gives this aldehydes. They give this haloform test. So these compounds which have either CH3CO or CH3CHOH group present in them, they oxidize themselves with the sodium hypohalite. What is sodium hypohalite? Sodium hypohalite is NaOX. That means it may be NaOI. That means it may be NaOCl. That means it may be NaOBr, which is produced by the reaction of NaOH, and so this is how they are produced by the reaction, and you get, see, NaOX is known as the your sodium hypohalite. It may be NaOCl, NaBr, or NaI. Generally, this reaction takes place in this manner. So let us move forward. The methyl group is okay. So once again, my dear students, let start that the aldehydes and ketones that have CH3CO group or CH3CHOH group are oxidized by the sodium hypohalite to sodium salt of corresponding carboxylic acid. The product is sodium salt of carboxylic acid, and this is how the methyl group present in CH3CO group or CH3CHOH group. This uh, methyl group is converted to haloform, which may be chloroform, bromoform, or iodoform, and this is how we call this test as a iodoform test. This oxidation does not affect the carbon-carbon double bond. Remember, this oxidation does not affect the carbon-carbon double bond. We will see it with one example also, that when we do such kind of oxidation, if there is a carbon-carbon double bond present in the alkyl chain, this carbon-carbon double bond is not affected by this kind of oxidation, my dear students. So let's move forward and see what happens. If we have RCOCH3, that is a ketone which has got CH3CO group, which is this CH3 is converted to CHX3. This CH3 is converted to CHX3, my dear students, and this RCOO is converted to RCOONA. So you can see that this ONA combines with RC double bond O, and C has got 3X to be bonded with it. X can be Cl, Br, or I. There is only one aldehyde which has got aldehyde that give haloform test, and it is acetaldehyde, because acetaldehyde has got CH3CO group present into it, and that is why only acetaldehyde give haloform test. The other aldehydes do not give haloform test. Let us see how acetaldehyde give haloform test. This is your acetaldehyde that reacts with NaOI. It gives sodium format HCOO. This HCOO group is bonded to ONA. So HCOO-ONA, that is known as sodium format, and you get iodoform CHI3. Same way, my dear students, there are few compounds which will definitely give this test that I am going to share with you. They are all the two ketones. That means it may be the 2-propanone, 2-butanone, 2-pentanone, 2-hexanone. They all have CH3CO group, and that is why they can give you the haloform test. Same way, my dear students, 2-propanol, 2 alcohol, that is, you can have 2-propanol, 2-butanol, 2-pentanol, 2-hexanol, irrespective of the number of carbon bonded as an R. As CH3CHOH group is present, these all alcohol give the haloform test. So let us see a few example. This is the example number 2. that you have two butanol which undergoes the NaOCl. So this CH3 turns into CHCl3 and the rest of the part CH3, CH2, COO and we get this ONA bonded to it. So this is how my here the reaction takes place and from 2-butanol we get sodium propanol and chloroform. Now we have one more example with the alcohol. If you have 2 propanol, this CH3 turns out to be CHI3 and CH3 C double bond O ONA. This ONA bond here and you get CH3 C double bond O ONA and you get sodium acetate and iodoform. Now I told you my dear students that if there is a double bond present into the R, this is RCOCH3. So if there is a double bond present into the R, this double bond is not affected, it remains the same. Only this CH3 turns out to be CHI3 and rest of the part, this C double bond O Na is simply, this C double bond O is simply bonded to ONA and this is what it gives us the final product. So you can see CH3 CH double bond C CH3 CH3 CH double bond C CH3 and CO are not affected at all. ONA is bonded to it and iodoform is formed. Remember that these double bonds are not affected at all by the iodoform test. So this is how, my dear students, we understand about the various oxidation processes that we have studied. So let us revise, my dear students, whatever we have studied today. Let's do a simple revision for whatever we have seen. Today we have first, I'm going to change the sharing because for revision we need to go to the previous PDF. In the today's class, I hope you can see the previous uh, share previous PDF. Today we have started studying about the addition of ammonia and its derivatives. We have seen that by the addition of ammonia and derivative, we get imine or substituted imine, oxime, hydrogen, phenyl hydrogen, and semicarbazide. Same way, my dear students, we have studied about the clemenson reduction and wolfkishner reduction. Clemenson reduction use ZnHg oblique HCl as a reagent, whereas wolfkishner reduction use hydrazine as well as the KOH in ethylene glycol. Both this compound, both this reduction, they simply gives us the alkane or hydrocarbon. So clemenson, ZnHgHCl, wolfkishner, NH2NH2 oblique KOH in ethylene glycol, they both convert the carbonyl group to the respective alkane by removing one oxygen and adding two hydrogen. Then we have studied about the oxidation, my dear students. We have seen that aldehydes, when they are oxidized, they give a carboxylic acid. Same way ketones also give carboxylic acid in the vigorous condition, means at high temperature and pressure, and in the